Look up at the night sky, it is filled with countless stars. Each one is a sun, perhaps with its own worlds. Those stars are gathered into a vast city of light we call the Milky Way. Our galaxy is immense, a swirling disk, gas, dust, hundreds of billions of stars, but at the very heart lies something truly extraordinary. A place of absolute darkness, a point of unimaginable gravity. A secret the universe has kept for billions of years. A monster lurking in the dark. This is not fiction, it is a supermassive black hole, so dense, so powerful, nothing can escape its grasp, not even light. Imagine a waterfall flowing over its edge. Now imagine it pulls in the river banks, even the sky above. That gives you a small idea of what we're dealing with. Not just curiosities, fundamental parts of the universe, anchors around which entire galaxies spin. Our journey to understand them is one of the greatest adventures in science. We cannot see them directly. So, what exactly is a supermassive black hole? In simple terms, it is a huge amount of matter squeezed into an incredibly small space. Think of our sun. It is enormous, more than 1,000,000 times the size of Earth. Now, imagine crushing the sun down until it is only a few kilometers across. The gravity of that tiny object would be immense. A black hole is even more extreme. A supermassive black hole is not just one sun crushed down. It is millions or even billions of suns all packed together into a region of space smaller than our solar system. We find these giants in a very specific place. The center of almost every large galaxy, including our own Milky Way. Our galaxy's heart is home to a supermassive black hole called Sagittarius A. It is located about 26,000 light-years away, hidden behind thick clouds of gas and dust. For centuries we looked without knowing what was truly there. It was a mystery. A source of powerful radio waves. Now we know it is the gravitational heartbeat of the Milky Way. How do these monsters form? This is one of the biggest questions in cosmology. We are not entirely sure. One idea is they started as smaller black holes from the collapse of the very first giant stars. Over billions of years, these smaller black holes merged. They also grew by feeding on vast amounts of gas and dust. A cosmic feast that lasted for eons. Each star consumed, each gas cloud devoured, added to its mass. This process is what makes them supermassive. It is difficult for our minds to grasp the true scale of these objects. Words like big or massive do not do them justice. Let's return to our own supermassive black hole, Sagittarius A. It has a mass equal to about 4 million of our suns. All of that material concentrated in a space that would fit inside the orbit of Mercury. It is an astonishing concentration of matter. Yet Sagittarius A is modest compared to the giants out there, like a lion in a universe of greater beasts. Some galaxies host black holes that are truly mind-boggling. Consider Messier 87. Its central black hole was the first we photographed, a triumph of global collaboration. This black hole contains the mass of 6.5 billion suns. Its event horizon is the point of no return. Our entire solar system out to Pluto could fit inside it. Light itself would take days to cross its diameter, and there are even larger ones. The current record holder, TON 618, is estimated at 66 billion times our Sun. It is an object of almost mythical proportions. If placed in our solar system, its influence would be felt far beyond the planets we know. These are the true giants. They challenge our understanding and force us to confront the extremes of nature. They are places where space and time break down. At their center lies a singularity, a point where our physics may fail. Thinking about these objects is a humbling experience. Supermassive black holes are not just passive objects. They are active and powerful engines that shape their surroundings. They are the architects of their galactic homes. One way they act is by regulating star formation. A galaxy is a nursery for stars, filled with giant clouds of cold gas. If left alone, this gas would collapse to form billions of new stars. But this does not always happen. As gas and dust fall toward the black hole, they form a swirling, superheated disk, the accretion disk. Friction and gravity heat the material to millions of degrees, making it shine brighter than all the galaxy's stars. A quasar. The intense energy heats surrounding gas, preventing it from cooling and forming new stars. The black hole, in effect, decides when and where stars can be born. Sometimes the black hole ejects gas entirely. Powerful magnetic fields grab material and launch it outward in two colossal jets. These jets travel near light speed and can extend for hundreds of thousands of light-years, reaching beyond the visible edge of the galaxy. They act like cosmic snowplows, clearing gas and dust and suppressing the birth of new stars. The black hole is both consumer and creator, shaping vast structures. This relationship is a delicate dance. There seems to be a connection between the mass of the central black hole and the galaxy's bulge. The bigger the bulge, the bigger the black hole, suggesting they grow together in a feedback loop. We are only beginning to decipher this cosmic conversation. Our journey of discovery has been remarkable. A century ago, supermassive black holes were just a strange prediction of Einstein's general relativity. Today, we have photographed them, watched stars dance around them, and seen the shadows they cast upon the cosmos. We know they are real, we know they are powerful, but for all we have learned, the greatest mysteries remain. We stand at the shore of a vast ocean of ignorance, and our questions are more profound than ever. What happens inside a black hole? Einstein's equations predict a singularity, a point where space and time end, but this is likely where our physics fails. Does a new kind of physics take over? A quantum theory of gravity that unites the very large and the very small? Could a black hole be a gateway to another universe? Or is it simply a place of ultimate destruction? We do not have the answers. To find them, we need new theories, clever experiments, and bigger telescopes. The universe is expanding. Eventually, the fuel for galaxies runs out, the stars will fade, the gas clouds will disperse. Supermassive black holes may be left alone in the cold dark. Stephen Hawking predicted they can slowly evaporate over unimaginable timescales via Hawking radiation. If true, these eternal monsters may one day disappear, returning their energy in a final faint whisper. These questions drive us forward. They push us to build, to test, and to think more deeply about the nature of reality. They are the ultimate cosmic laboratories. The dark giants are waiting.